Hi guys, can someone confirm if you're able to hear me? Cool. So let us get started. So agenda for today's live is that we will do some questions on stack and queue. In the previous session, I think we discussed stack and queue. So today we will do maybe one question on stack and queue, and then we will try some other topic. We'll try to revise a little bit of sliding window, or we will do one question on linked list also. Okay. So that's the plan for today. Let us get started. So first let us do a question on queue and then we will move ahead. So the last question that we did on Tuesday was implementing queue using stack. Okay. So today let us do the reverse of it. Implement stack using queue. Somewhere the logic will be similar, and after that we will probably touch upon sliding window or some other concept. We'll try to do two or three questions. Let me open Leetcode and let me look at stack using queue. Okay, let us do 225. Question number 225. Hi Ashish, hi Manpreet, Saif, Tyler. So this is the question. Just give it a quick read and then we'll start. But I hope the question, the title itself should be clear. 225 implement stack using queues. Okay, let me start. So guys, do you remember the logic that we used for implementing queue using stack when we were trying to implement a LIFO using FIFO? How did we start or how did we approach the problem? We started by sorting our idea into what is a queue, what is a stack, and if we want to implement a stack, what is the functionality or what is the interface that we want, right? And sorry, we are trying to implement queue. So what is the functionality we want? We want a NQ and a DQ function. Okay, and what do we have? We have a stack. So what can we do in a stack? We can do a push and pop. So using push and pop, how can we simulate NQ and DQ operation? Now we need to do the opposite here when we are implementing stack using queue. Okay, so we need to implement a stack. So stack will have again push and pop. These two functionalities we need to implement, and what we have with us is queue. So in a queue we have NQ and DQ. Okay, now if I try to, we'll read the question in a while, but I'll just give you a brief overview that we want to implement something like this, a box, maybe something like this, and this should behave as a queue. Sorry, not queue, stack. Ulta. This should behave as a stack. Okay, so we can do, we will be asked to do push 10. So we should put the value 10 here somewhere. Inside we will have a queue or something, whatever. What we will have that we don't know, but we'll have push 10, then we will do push 20, and then we will push 30, and then we will pop. Okay, so if we pop, what should we get? We should get 30. Okay, but inside this we have a queue. We have to use one queue, two queue, whatever, but inside the box we are going to use queue. Okay, and using the queue we need to implement this. So if we are using a queue and if we push the values, okay, if we push 10 and if we push 20 and we push 30, okay, and then we try to pop or if we try to DQ, we are going to get a value 10 because this is a queue, right? But actually we want this value 30. So somehow we need to reverse the order in order to achieve this functionality. Okay, because in a stack, okay, you put the value here and you remove the value from here. But in a queue, you push the value here, but you remove the value from here. Okay, but we want to remove this value, so somehow we have to flip this. Okay, so that is the high level idea that I am getting in the question, right? I'm not giving you the solution, I'm just telling you the way to think in these problems, right? So first, on a very high level, we have to be very clear on what we want to do. Okay, what is the general strategy or high level strategy, and then we have, and after that we have to figure out how to do it, like what will be the code, how will we go step by step in that direction. So I think the high level intuition should be clear to all of you guys. Tell me in the chat, please. Are you guys following? Okay, so here also we are going to use, and then we also have to think about the time complexity, right? So what is going to be the time complexity? Right now we don't have a solution, so we don't know, but we'll try to think of the time complexity. Okay, so now let us try to simulate it. We are going to use two queues here, because very obviously we know that we have to flip things, we need to reorder or reverse things. Okay, and if you want to reverse a stack or a queue, you need two stacks or two queues. Okay, so let us say that I will take two queues here. Let me take one queue here and let me take one queue here. Okay, and the interface is going to be that of a stack. Sorry, the yes, interface is going to be that of stack. So in a stack, someone can say push 10. Okay, so I can push 10 here. Let me call this my main queue, and let me call this my helper queue. Okay, so if I'm implementing a stack, someone can ask me to push a value of 10 on the stack, right? So I'm pushing the value 10, so it's going here as 10. Okay, then someone is saying push 20. Okay, so I'm pushing 20 here, no problem. Okay, but if someone is saying pop, okay, then we will dequeue and we will return 10, but actually we want to return 20. We don't want to return 10, we want to return 20. Okay, so ideally what we want is that when we are doing this push and pushing the value, we want to push in such a way such that the elements order is reversed. Ideally we want it to look like this, 20 and 10 somehow. Okay, we want to do it like this. So what I will do, I will arrange for some way for this manipulation to happen. Okay, so whenever I am pushing something, I will push it in the helper queue. So I have the value 10. So I'll put it in, I'll put 10 here. Okay. Helper queue is empty. I'll put it in 10, and main queue is empty. So I will not do anything. Then when I have to push 20, okay, and I will swap this. I will make this the main queue and I will make this the helper queue. Okay. I have swapped it. Now you see helper queue is empty. Now what I will do, I have to push 20. Okay, so earlier also I added 10 to the helper queue and then I swapped it. Again I am pushing 20, I am pushing 20 to the helper queue. Okay, and I will empty the main queue. So main queue can be emptied, I can do a dequeue here. Okay, and I can put 10 here. Okay, and once I have done that, I will again swap the helper queue and the main queue. अदली बदली कर देंगे. ठीक है, अब आप देखो हेल्पर क्यू फिर से खाली हो गया. ठीक है, हेल्पर क्यू फिर से खाली हो गया. इसका करने का फायदा क्या हुआ? वाई आर वी डूइंग दिस? वी आर डूइंग दिस बिकॉज इफ नाउ समवन इज आस्किंग मी टू पॉप, okay, I will be able to return 20 because it is in ulta order. So why did we do this main queue, helper queue and swapping? So that we can reverse the order. And if you remember, in the previous question also we did something like that. We were using two stacks and we were using one stack to reverse. Okay, because in a stack and a queue, when we are doing pop, the expectation is just opposite. Okay, if it is a pop in a stack, we will remove 10, but if it is in a queue, then we will remove 20. Okay, So now let's say that we have to pop something. So if we have to pop something, I can directly remove this 20 and I can give. But let me not pop. Let me say that I want to add something again. So I want to say push 30. So when we have to push, what I'm saying, when we do push, because in a stack we need to implement push and pop. So I'm saying when we do push, I'm saying push to helper queue and then transfer all elements from main to helper. Okay, so now all the elements are there in helper but in reversed order. Okay, and then what we will do, we will swap main and helper. So when we do this, helper is again empty. So next time we have to push, again we will push to helper queue, transfer all the elements from main to helper, and then swap main and helper. Guys, is this idea clear? I'll do push 30. So I'll push it to helper queue. And after doing that, I will dequeue from the main queue. Okay. So I'll take out this 20 and I will put it here. So this 20 is gone. Then I will dequeue this 10 and I'll bring it here. So now this is also empty. Okay. And then I will swap these two. Helper will become main and main will become helper. Okay. Now you see my main queue is having all my elements. I actually pushed 10, 20 and 30. So the stack should look like this. Stack should, if this was a stack, it should have looked like this: 10, 20 and 30. So if we pop, we should get 30. And here also you see it is in the same order. Although it is a queue, so we are going to dequeue, but 30 is in the right position. I hope you understood why we have done all this. Okay, so if we pop, we will use the dequeue and the dequeue will give us the same result as expected by pop. Again, if you want to push something, if suppose we want to push 40, we'll push to the helper queue. Here is my helper queue. I'll push 40 and I will dequeue everything from the main. So 30 will go here. I will remove 30. 20 will go here. I will remove 20 and I will remove 10. Okay. Now my main queue is empty. I am just going to swap these two. So this will become my main and this will become my helper. My helper is again empty and my main queue has all my elements in reverse order. ठीक है, अब इसका टाइम कॉम्प्लेक्सिटी को डिस्कस करते हैं. So what will be the time complexity? Can someone tell me in the chat, please? What will be the time complexity? But if we add and swap from helper to main queue, it will take time complexity as O of n. Correct. So it will be O of n. It can't be O of 1. It will be O of n. Every time we have to push, we have to swap the things. So here I'm using two queues. Here I'm using two queues. You can also solve this using one queue. Okay. You can also do it using one queue. Although it is not very intuitive, but you can do it using one queue also. How will we do using one queue? Constantly you will have to keep shifting every time you push some element. What you can do, you can take this like this, take one queue like this. Okay. And suppose someone says push 10. So I'll push 10. Okay. And then someone says push 20. Okay. So we can push 20 here. And after that, I can dequeue this and enqueue it again. Okay. So I can remove this 10 from here. Okay. And I will enqueue it back. So now you see it is in the reverse order. Ashish is saying we can use deck. See, if you use deck, then technically you are not using a stack. So deck you can use. In fact, we will use a deck only. But when we are using a deck, we will limit ourselves to using it only as a normal queue. Because if you use double-ended queue, then question does not have any logic. Okay, so you will see that it is mentioned somewhere in the question. So if you say push 30, okay, so we will push 30. We will push 30, but after that we will dequeue all the elements before 30. Okay, this 20 we will dequeue and we will enqueue it back, and this 10 also we will dequeue and put it back. So now you see again it is in the reversed order. it should have been 10 20 30, but it is actually 30 20 and 10. So every push we are pushing the we are enqueuing the element and then dequeuing all the elements before that and enqueuing it again back, so that it becomes reverse. So we is asking, in this, how we know what was the end and what is the beginning if we use only one queue? You will have the pointer, right? Up till that value, suppose I have to enqueue again something. Suppose I have to enqueue 40. So up till this, all these elements, one by one, you will dequeue and enqueue, dequeue, enqueue, dequeue, enqueue. Three times you will have to do. Okay. Let us try to write the solution using two queues. One queue you will see, or you can take it upon on your own to write it. So let us read the question first. Okay. So we need to implement a stack using queues. So it says implement a last in first out stack using only two queues. So here already it is told to us that we have to use two queues, but you can use one queue also. The implemented stack should support all the functions of a normal stack, which is push, pop, top, and empty. So top and empty is not a very big deal, but push and pop we know how to do. Well, when we'll push the element and then reverse. Somehow we'll figure out a way to reverse the order of the queue. Okay. So we'll have to implement a my stack class. We will have a push. We'll be given a value. It will not return anything expected. Then we'll have a pop value. It will return an integer. We'll have a top value. It will return an integer, and we'll have an empty value which will return a boolean. So how will we decide if the queue is empty? Size of the queue will be empty, 0. Then we'll get to know. Okay. So you can implement this using a deck. So we will use for implementing queue we will use a deck. Okay. So let us get started. Okay. So what did we decide? We will take two queues. Okay. So we'll say self dot main queue. Let me just check the chat once. Okay, no problem. We'll use a main queue and we'll use a deck. Okay. And we'll use a self dot helper queue. And here also we'll use a deck. Okay. So when we are pushing, what do we need to do? Okay. What do we need to do? What are the things we discussed? We will push to helper stack. Okay, we'll push to helper stack. After that, we will dequeue all elements from main stack and add to helper stack. And then we will swap the main and helper stack. Keep in mind that these steps you need not keep in your mind, but what you need to keep in mind is the high level idea. High level idea is that the queue elements should be reversed. So we have to figure out a way to reverse it so that the first element comes last element comes first, then only it will behave as a stack when we pop it. Okay. So for push, what we need to do? The first step is to push to helper stack. So we'll say self dot helper stack dot append. What do we append? X. Okay. And then we need to dequeue all the elements from the main stack. So we'll say while self dot main stack main queue, sorry, main queue, not helper stack, helper queue. Here also it will be queue, helper queue. Okay. While main queue, what we'll say? We'll say self dot helper queue dot append self dot main queue dot pop left. Okay, we are popping from the left side, and these are the only two operations that we are going to allow: append and pop left. You will say that there is a functionality for pop also, or append left also in a deck. It is there, but we will not use it because we have to use only the standard operations. It says that you must use only standard operations of a queue, which means that only push to back, pop from front. Okay, from one end we have to push, other end we have to pop. We can't use a deck functionality. Okay, so we'll do this, and after this is done, then what we will do, we will swap. Okay, so how do we swap? We can say self dot main queue and self dot helper queue is equal to self dot helper queue and self dot main queue. Okay, this part is done, pushing part is done. Now if we have to pop it, we don't have to do anything much. We'll just simply return self dot main queue dot pop left. Okay, this is going to solve our problem. Okay, if we want top, then we can just simply return self dot main queue 0, the first element. Okay, and empty we can just simply return if length of self dot main queue equal to 0. Okay, I hope I have not made any typo. Let us run and see. It is working. Let me submit. Yeah, it is working fine. Guys, did you follow? Let me add this question in our sheet so that you guys can revise it later. You can also solve it using one queue. I'm leaving that solution. I'm leaving that for you to try it out. Stack and queue वाले में ऐड कर देता हूँ. Okay, try to solve the same problem using a single queue also. Single queue. You can solve it. What you will have to do for that? Simply you will append it. Let me make some changes here. Let me write that also. Okay. So while pushing, we'll use the main queue. We'll not use the helper queue. Okay. And we'll not use this. Uh, so we will add it to the helper queue, and then we will write a for loop. Write a loop to dequeue all the elements before X and enqueue it back. Okay, so how will we do that? We'll say for in range. Okay, length of self dot main queue. You see what we will do. Mm, let me figure out what will be the length here. So you see, if you have suppose 10, 20 and 30, and you have added 140 here. Okay, so you have to iterate this much. Okay, so we have to iterate for length of queue minus 1. This will be the range. Okay, and we will dequeue the element. Okay, we will dequeue the element. We will pop from here and enqueue it back. Okay, so we'll pop left and enqueue it back. That is the logic. So we'll say length minus 1 Okay, we'll say self dot main queue dot append. What will be append? Or let me say pop left. Okay, and this value we are going to append back to self dot main queue dot append. Okay, main queue dot pop left, this will be the same, and top will be same, main queue 0. Okay, did you guys get this? I'm using only one queue, so let me run this and see. क्या हो गया? यहाँ पे मेन क्यू आएगा. सॉरी, सबमिट करके देखते हैं. दिस इज ऑल्सो वर्किंग. ठीक है, ये वाला सोल्यूशन भी लेट मी पेस्ट इट इन द chat, the text. Sorry, it will be the code. Guys, all of you understood both the approaches? Let us do one more. Now we'll not do anything on stack and queue. We have solved, I think, 5-6 questions. Let us solve one question on linked list. Okay, let us shift our focus from stack and queue and let us go back to linked list. So linked list we did long back, so we'll revise maybe some questions. So let me go back to our sheet and mark few questions as done. So we have done stack and queue. कहाँ है? Okay, next data element ये कर लिया हमने. Stack using queue ये भी done है. Okay, and implement queue using stack is also done. Phone. This is also done. Okay. Design circular queue is also one very good question. Uh, okay, you can try this out. Design circular queue. This will be a good question for you. This is nothing but doubly linked list ka application. Okay, you can use this. You can do this. You can use multiple approaches. I have shown you array wala approach, linked list wala approach, so you can do that. Circular deck is there, that also you can do. Sorry, circular deck wala application will be doubly linked list, and circular queue you can do using arrays also, and you can do using normal linked list also. Okay, so both of these will be you can solve these two questions. Okay, so let us go back and 739. Some of these questions are duplicate actually. Okay, so delete that. I will delete it, don't worry. Let us go to linked list and let me solve. कौन सा करें? Let us do this one. 138. It's a good question. You will get some idea of hash maps also. Let us see. 138. I have also not solved this question actually. Let us read this question. Guys, anyone having any question, doubts still here? Can we move ahead? Let us read the question and try to understand. Okay. The question says that we need to copy list with a random pointer. What is this random pointer? Let us say it says a linked list of length n is given such that each node contains an additional random pointer which could point to any node in the list or null. Okay, fine. It means that normally we have a linked list like this. Okay, and every node is pointing to the other node. Okay, this question is saying that every node is not just having the next pointer. Okay, in given such that an additional random pointer, it has additional random pointer means it can point to some random node. Okay, it is pointing to the next node and it is also pointing to some random node. Fine. And we need to construct a deep copy of this list. The deep copy should consist exactly n nodes, brand new nodes. So you know about shallow copy and deep copy. When we do deep copy, we don't keep references to the original. We create new memory addresses. Okay, so we will create new memory addresses where each node has its value set to the value of its corresponding original node. Both the next and random pointer of the new node should point to the new nodes in the copied list, such that the pointers in the original list and copied list represent the same list state. Basically, we have to create a deep copy. Okay, the entire thing is just a description of what a deep copy is. None of the pointer in the new list should point to nodes in the original list. Fine, in the deep copy we will not do that. Okay, so I think that is the question. Let us try to see some example if we can make sense of that. It says return the head of the copied linked list. Fine. It says linked list is represented in the input output as a list of n nodes. Each node is represented as a pair of value and random index, where value is the integer representing node.val and random index is the index of the node from 0 to n minus 1 that the random pointer points to, or null if it does not point to any node. So it tells us that random pointer can point to some node or it can point to null. So null. So you can see this example. If you look at the example, it probably will be able to relate to it. Okay, so this is the example. What's the time, by the way? 9:37. Fine, we have time. Okay, so this is one node. Okay, this is one node, and you see it has a next pointer and it has a random pointer. So next pointer is pointing to this. Here also next pointer is pointing to this. Next pointer is here. Next pointer is here. So this is a normal linked list. But other than the next pointer, it also has a random pointer. So random pointer is pointing to some random node. So this random pointer is pointing to null. Fine. इसका random pointer is pointing back to the first node. इसका random pointer is pointing to this node. इसका random pointer is pointing back. And इसका random pointer is ये किसका random pointer है? ये कौन सा है? Right, sorry. इसका random pointer is going back here. Okay, basically all the nodes they are having some next pointers and random pointers. So how are we going to do this? Okay, and copying a data structure is something that you will see very commonly even when we are learning about trees and graphs. We will have questions of creating a copy of the graph or create a copy of the list. Okay, so the approach that we are going to see will be applicable to other questions also. Okay, so what are we going to do? What can we do? Let us try to take this question separately and try to understand what can be an approach. So the question is, let me take this example, put it here. Leetcode 138, copy list with pointer. So what I'm thinking is that the fact that the list is having a random pointer should have nothing to do with the actual logic. Okay. Even if it was a normal linked list, the logic would have been same. So let me create a simple linked list first. Okay, this is my linked list. Let me see the chat. Okay, so here we are having some next pointers like this. We are having some random pointers also. So maybe this random pointer is here. This random pointer is null, and this random pointer is here. Okay, the pink ones are random pointers, and the yellow one is the next pointer. Suppose this is the question. So first of all, if we have some nodes, maybe this is my node A, this is the node B, this is the node C. So we need to create three more nodes first of all, which will be A, B, and C. Okay. So the copy of A will be maybe A2, this will be B2, and this will be C2. Let me call them A1, B1, and C1. Okay. So A2 is a copy of A1, B2 is a copy of B1, and C2 is a copy of C1. This work we can do. There is no problem. We'll start with a current pointer here. Okay. And we will find out what is the value of this. Maybe the value of this is 10, this value is 20, and this value is 30. So we will go to A1, we'll find out the value, and we'll create a new node called A2 with the value 10, B1 with the value 20, and C1 with the value 30. C2 with the value of 30. So A2, B. So three nodes we have created, which are clones of the given nodes. Now the next step is we need to make the connections. Okay. So the fact that A1 is connected to B1, okay, and A1 is connected to C1. This is the next pointer, and this is the random pointer. So based on this information, we need to say that A2 will be connected to B2, okay, and A2 will be connected to C2, the random pointer. Random pointer of A2 will go to C2, and next pointer of A2 will go to B2, right? So if we create this mapping, then if we again iterate, so first we will iterate and we will find out all the values, we'll create all the nodes. Then the next step will be to create the connections. So while creating the connections, we can go to this A1 and say that okay, A1 is connected to B1. Okay, so corresponding to A1, what do we have? A2, and corresponding to B1, what do we have? B2. So if A1 is connected to B1, then A2 will be connected to B2. So that mapping we will have to create somewhere. So we'll create one mapping that A1 का clone is A2, B1 का clone is B2, C1 का clone is C2. We'll create one map, and from this map we'll go to A1, okay, and we'll say okay, A1 का next is B1. So A1 के corresponding we have A2, and B1 के corresponding we have B2. So A2 and B2 will be connected. So A2 and B2 is now connected. And A1 का random pointer is C1. So C1 के corresponding is C2. So A1 का random pointer will be C1. Like this we will make the connections. Did you guys get the approach? What we are going to do high level? We have not written the code, but still. Online guys, please tell me if you have understood. Is the strategy clear? Even I have not written the code. Let us write a pseudo code, because and then we'll write the actual code. Okay. So what we'll do? What is the first step? What is the first step? Okay. The first step is to create clone nodes. I'm calling it clone or deep copy, whatever you want. Okay. So we'll say we'll put the current. We will put the current on head. Okay, and we'll say while current. Okay, we'll create a new node which will be node of current dot data. This is the new node. Okay, and this new node we will attach it in a map. Okay, so we'll create a map also. Guys, correct me if I'm doing something wrong. We'll create one map. Okay, and we'll say map of original node. So what is the original node? Original node is current. And what is the duplicate node? Duplicate node is node. Okay, and we'll say current is equal to current dot next. Okay, so this step will do what? It will create 3 clone nodes. Are you guys following? Anil is saying that space complexity will be O of n. Yeah, so space complexity. See, why will space complexity be O of n? Because you have to return a clone. So the question itself is asking you for a new copy. So for that, you will have to have you'll have to create a new list. But yes, this will be an extra space. This map will be an extra space. Yes. So that O of n we have to do. There's no other way. Or there might be some way, but that's what is coming to my mind right now. I'm not right now. I'm not able to think how this will be optimized. Later on, we can think about that. But first solution that is coming to my mind is this. Okay. So we have done this much. Then what we have to do? The next step is to create connections. So how will we do that? Create connections. So how will we create connections? Again, we will put the current on head. Okay, and we'll say while current. Okay, what we have to do? We'll say that which is the current. We'll say uh, the original node. What is the original node? Original node will be current dot next. Okay, so this is the next pointer. Okay, iska clone. Where will we find a clone of this? How will we find clone of this? From map. Okay, this is the clone of the next pointer of current. Okay, this should become next of what? This should become next of what? This should become next of map of current. Okay, this is the cloned node. Cloned node का next should become original node का next का clone. Is this correct? This is the new node. Okay, this is the new node. New node का next, new node का next becomes equal to original node का next का clone. Okay, similarly, or what I can do here is I can put here clone for your readability. I think you may not understand. So I'll say clone is equal to map of current. And here let me make it clone ka next, because we want to create connections in our clone. Okay, and there are two connections. One is clone dot next and we need clone dot random. So clone dot random क्या होगा? ओरिजिनल नोड का जो रैंडम है उसका क्लोन. Okay, and then we will do current is equal to current dot next. किसी को समझ में नहीं आया तो आप प्लीज टेल मी, आई विल एक्सप्लेन इट वन मोर टाइम. Did you guys follow? Sumit, Manpreet, Anil. What this line is doing, okay, let me show you. If this is the original, I told you this is suppose A1, B1 and C1, and it is having some connection like this, and there are some random pointers. Okay, so this is the random pointer, this is the random pointer. Okay, so if we create a clone, this is our clone. So we are iterating on this. So this is my current. Okay, so map of current, this is E2, this is B2 and this is C2. Okay, so if we need this node, this is my clone, so how will we get it? We will get map of current, because this map only contains that A1 is belonging, A1 and A2 are connected, B1 and B2 are connected, C1 and C2 are connected. So we'll go to A1 and we'll go to A2. So A2 will give me this link. Okay, then I want to find, make this connection. So B2, how will we get? We'll get current dot next. So this is current dot next. Okay, so current dot next ke corresponding we have B2. How will we get it? We'll get it from this map. So if we say map of B1, B1 means current dot next. So map of current dot next, okay, will give me this B2. Okay, so this basically is B2 and clone is basically B1. So I'm saying B1 dot next is equal to B2. That's what I'm doing here. Similarly, same logic for random also. All of you guys understood? Can we try to write the code? Okay. So the first step is to iterate on the original list and create clones. Okay. So we'll say current is equal to head, and we'll say while current, we'll say new node clone is equal to node. Node ka class is already given here. Okay, so here we have val and next. So node will say val. What is a val? Val is equal to current dot val. Okay, this is a clone, and we will create one map also. We'll say mapping, map what is reserved. So we'll say mapping of current is equal to clone. Okay, and then we'll say current is equal to current dot next. Okay, guys, all of you are with me so far. Then what we need to do again now, iterate again and create the connections for the clone nodes. Okay, so again we'll say current is equal to head, and we'll say while current. Okay, we want to first find out the cloned node. So how will we find the cloned node? The cloned node is mapping current. Okay, let me save it as clone. Okay, and we'll say clone dot next. What is clone dot next? Original के next का clone. So original का next will be current dot next, and इसका clone is stored in the mapping. Okay, and we'll say clone dot random will be mapping of current dot random. ठीक है, and we'll say current is equal to current dot next. I have not read the question properly. uh, will return the head of the clone. So head of the clone is where? Mapping of head. Let me run and see. I think I may have missed some null pointers and other things. Correct. What is happening? Self.val node. Uh, it is X for some reason. X. अच्छा, ठीक है. Not working. क्या हो गया? Key error none. 7 null. अच्छा. Okay, so next and random pointers can be null also. Okay, so here we have to write condition if current dot next else none. We'll say if current dot, because the current and random pointer can be null also. So if it is not existing, then we'll put none. Let us see if that works. It will be there in the question because I did not read the question completely. We should actually read it. There is one more edge case you can see here from the constraints, that it is possible that there can be zero nodes also. Okay, so does our code handle that situation? If there are no nodes, then what will happen? If there are no nodes, then our current will be at the head and will not create any clones. Okay, so that is not, that is a problem. So let us submit and see. I think it will fail when there are no nodes. See, when there are no nodes, then our code is failing. I thought so. So what we can do here is we can say if not head, okay, then return none. I'll just write here edge case when the given list is empty. Okay, so I've already always told you that when you are working with linked list and any such things, boundary conditions you should always check. So always keep your one eye on the constraints. चल जा भाई, चल गया. Okay, so did you guys understand? So I'll take this question and put it in our sheet. This is a good practice for hash maps also and linked list also. So these type of questions you can expect. Okay, these are very logical questions. Linked list wale section mein I will add it. So what is the time and space complexity of this? Time complexity is O of n, because we are iterating two times, so it is 2n. Okay, we are making two passes on original, on given list. Okay, and space complexity, someone has already pointed out that it will be O of n uh, to create the mapping. Okay, time complexity, Priyanka, you're saying O n squared. Why O n squared? It will be O of n only, because you are iterating on the actual list when, and then you are creating new nodes. So all creating new node, creating connection, all of that is constant time. So you are just iterating once to create the clone, and again you are iterating. First you are iterating to create the clones, again you are iterating to create the connections. So it is 2n, or you can say n. Space complexity is also O of n. Yes, that is a question. Okay, it's 10 o'clock, so I want to do one more question, but let's stop here, and then we'll do it. Okay, next time we'll do we'll do revision of sliding window also. स्लाइडिंग विंडो पे कुछ क्वेश्चंस करेंगे, तो ये वाले क्वेश्चन को हम लोग डन मार्क कर देते हैं, इस वाले क्वेश्चन को. ओके, you try to do this one. Okay, 79 please try to do. 79 will be good practice for you. Okay, nth node from the end of the list, this we have done, I think. No, nth node from end of the list, lead code 19. Lead code 19, I think we have done that. It's not marked as done. November 11 we have done it, I think. I remember dummy node, I think, yes. So इसको भी done mark कर देते हैं. Okay, see this one also you do, try to do 237, delete node in a linked list. Okay, then copy list with random pointer we have done. Reverse reorder linked list, this also you can do. Okay, so try to do few questions here and there, and we will also try to pick up some questions randomly. But I would like to do some sliding window next time. Okay, so we'll start with graphs, but we'll try to do some sliding window practice also. Okay, guys, that's it for today. We'll wrap up, and if anyone has any questions or anything, you can please let me know. Otherwise, do check out the channel. Uh, okay, and you can see all the previous live sessions here. We have done some 7 or 8 live sessions on stack and linked list and prefix sum and whatnot, binary search. We have done a lot of practice here, and you can also check out my playlist. For if you are beginner in Python, then you can check out the hands-on Python for beginners. Otherwise, you can check out the breakthrough DSA with Python series. Okay, and very soon I'll be uploading detailed video data structures also. So that's all, guys. Thank you. Bye and good night.